Hi Math 2 students. Today we are going to go over quadratic functions in standard form. So far we've been dealing with quadratic functions in vertex form, and that is this: y equals a times x minus h squared plus k. And you are easily able to find the vertex of the quadratic from vertex form, which makes sense. Now, standard form of a quadratic function is in this form. It's ax squared plus bx plus c. The a value is actually like the same thing that you would find in the vertex form. They're going to be the same, both in the standard form and the vertex form. And with vertex form, the one we've been dealing with, you get the vertex right away. Well, with standard form, you actually get your y-intercept right away. This c value on the end is your y-intercept, okay? Now, to find the vertex and the axis of symmetry in standard form, what we have to do is we have to calculate negative b over 2 times a. And, of course, our axis of symmetry is always x equals, so it's going to be x equals negative b over 2 times a. And the x-coordinate of the vertex, which is the axis of symmetry, is also negative b all over 2 times a. You're probably like, well, what does this mean? Where is Miss Slattery getting this from? I will show you how we find this from standard form, okay? And basically, the b and the a, these are just the coefficients on x and x squared. All right. So it says is 2x squared plus 8x minus 5 in vertex or standard form. Identify the y-intercept in the vertex. So this guy is going to be in standard form. And we know that because it is in the form ax squared plus bx plus c. All right. So the y-intercept is very easy to identify. The y-intercept is just your c value, okay? So keep in mind y-intercepts are always 0, comma something, right? Your input 0 because you're on the y-axis. And your output, in this case, should be negative 5. You could, of course, always check, like literally any function you have ever. If you plug in a 0, you're going to get your y-intercept out. So if I go and do that, you'll see that I'll get a negative 5 out. Right, I can go to my calculator and type this in. You get 2 times 0 squared. Whoops, sorry, didn't mean to click enter. Oh my goodness, didn't mean to type that 9 either. All right, it's definitely much easier to type on a physical calculator than it is this online one. There you go. So you can see when I plug a 0 in, I get a negative 5 out. And like I said, in standard form, it's just going to be that c value on the end there. Now, how do we find the vertex? It's a little bit trickier. We should be able to identify a, b, and c from looking at our standard form here. Our a value is 2. That's the number attached to the x squared. Our b value is 8. That's the number attached to the x. And then our c value is that constant on the end. Now, one thing to keep in mind is your b and your c could be 0. If there's no x term, your b is 0. If there's no constant on the end, your c is 0. However, your a cannot be 0. And the reason for that is if a is not 0, it's not a quadratic, because then that x squared term's gone. All right, so anywho, we've identified our a, b, and c, and as mentioned previously, to find our vertex, the x value of our vertex, we need to do negative b over 2 times a. So you're just going to take your b and you're going to do the opposite of b. Well, if my b is 8, my negative b is going to be negative 8. And then I'm going to do 2 times a. So 2 times, and then my a value is 2. So I get negative 8 over 4, which you could simplify very easily on your calculator or do in your head. You should get negative 2. So this is the x value of your vertex, okay? To find the y value, we're just going to go plug this in. We're going to go to our function. And wherever we see an x value, we're going to plug in a negative 2. So we're going to do 2 times negative 2 squared plus 8 times negative 2 minus 5. So again, wherever I saw an x value, I just put in my negative 2. Now, remember, when you plug in a negative, you need to put parentheses around your negative. I mean, honestly, whenever you plug anything into a function, put parentheses around it. But if you don't put parentheses around your negative, you're actually going to get it wrong. Oh, my goodness. All right, so I go ahead. Oh, my gosh, my fat fingers are just not having this. All right, so I go ahead and plug in what I just wrote there, and I get a negative 13. So that is my vertex, or I should say the y value of my vertex. All right, so again, when you are in standard form, you get the vertex from doing negative b over 2a. Then that gives you your x value. Plug that in to get your y value. All right. So these are our answers here. Now let's go ahead and take a look at part 2 here. This guy is in the form a times x minus h squared plus k, and we call that vertex form. That's the form we've been dealing with prior to this. Now, the easy thing to find from vertex form is the vertex. If you recall, you just switch the sign of this guy, keep the sign of this guy, right? So my vertex is going to be negative 8, comma, negative 5. Now, when you are in vertex form, this guy on the end is not your y-intercept, okay? So don't fall for that, okay? That guy in the end is only your y-intercept when you're in standard form. Now, for any function, to find the y-intercept, you can go ahead and plug in a 0 for x, okay? And that makes sense, right? Because if you're plotting on the y-intercept here, that means your x value is 0, all right? Oh, lovely. My mom made me a cucumber salad. Thanks, Mom. So because we're not in standard form, we can go ahead and plug in a 0 to get our y-intercept out. We have to do that. So we've got 2, and then wherever I see an x, I'm going to put in a 0. So 2 times 0 plus 8 squared. And we can go ahead and put that in parentheses if we wish, minus 5. So I'm going to go to my calculator, and I do 2 times 0 plus 8 squared, and then a minus 5. And I get my y-intercept as 1, 2, 3, 123. All right. Okay, so let's go ahead and take a look here at example B. All right. It says, what is the x of symmetry, vertex, and y-intercept of the function? And then they want us to graph it. So if you recall, when we graph, we need to have our points. So that's what we're going to do here. And we're going to go ahead and find, let's go ahead and find the axis of symmetry / the vertex. If you remember, the x value of your vertex is your axis of symmetry. So once you get that, you get your axis of symmetry. So in order to do that, well, I guess first we should point out that this is in standard form, right? So because it's in standard form, we can't get the vertex just from looking at it. We got to go do the negative b over 2a thing. So looking here, my a value is 2, my b value is 4, and my c value is 3. So my negative b is going to be the opposite of b, so I get a negative 4 all over, and then I'm going to do 2 times a, which is 2 times 2. That gives me negative 4 over 4, which gives me negative 1. So that is my axis of symmetry, and that is also the x value of my vertex. Now, if you recall, we got to put our vertex smack dab in the middle when we're graphing. So we can go ahead and do that, and then we can go and plug a negative 1 into the function here. So we're going to do 2 times negative 1 squared plus 4 times negative 1 plus 3. So we can go to our calculator and plug this in. So 2 times negative 1 squared, oh my goodness, plus 4 times negative 1 plus 3. All right, so my output is 1. So that means that the y value of my vertex is 1. Now, there's a couple of different ways you can go about getting the rest of this chart. You can of course, plug it into your graphing calculator. So now that we know where my vertex is, I know kind of where to center it. I can go and plug this into my y equals. Yeah. So I'm going to do y equals and then clear out anything I have in here. And I can just plug this in, right? I get 2x squared plus 4x plus 3. All right, and just like my vertex form, it's going to make a table that I can use here. So when I do alpha, second graph, it makes my table for me. And I can see that I do have my vertex -1, comma 1 there. I can do my 2 points ahead, which is going to be -3, 9, and -2, 3. And then my 2 points in front of here, which is going to be 0, 3, and 1, 9. All right. So then we can go ahead and plug in my values here. Oh, and another thing, we didn't find the y-intercept yet. All right, which actually, I guess technically we found it, but we didn't really need to use the calculator for it. Our y-intercept here is going to be 3, 0, comma 3, which if you can see, we've actually already got that on our chart here. So we can go ahead and plot our points. So we've got -1, 1, 0, 3, -2, 3, and our 9s are going to be off the chart here. So what, 6, 7, 8, 9, that would be right here. And then same thing here, which I know is not ideal, but what can you do? It's just off the chart. All right. So that is how we would graph that guy. All right, let's do one more. So again, this guy is in standard form. Okay, we can get our y-intercept easily. We'll do that first, I guess. The y-intercept here is going to be 0, comma 4, because it's in standard form, so it's that c value on the end there. Our a value, in this case, is actually going to be 1, because there's no number in front of the x squared, which means the coefficient's 1. Our b value is 2, and our c value is 4. So now we can go ahead and find our axis of symmetry and the x value of our vertex by doing -b over 2 times a, which is going to be -2 all over 2 times 1, which gives me -2 over 2, which gives me -1. So then I can go ahead, I know that my axis of symmetry is going to be x equals -1, and I can start making my chart. I'm going to put a -1 here, and then to get the y value of my vertex, I can just plug a -1 in. So I go to my calculator. I'm going to do -1 squared. Don't forget to put parentheses around your input, or else you might get it wrong. 2 times -1, and then a plus 4. All right, our output here is 3. So we can go ahead and if you for some reason don't have your graphing calculator, you could go through and like find the 2 points ahead. So like in front of -1, we've got -2 and -3, or I should say behind -1, and then in front of -1, we've got 0 and 1, just like you're counting. And to get your output, you could just go through and plug these in, right? So you would do like -3 squared plus 2 times -3 plus 4. And then just plug that into your calculator. So like my output here is 7. And you would, you can go plug in a -2, plug in a 0, and so on. We should already know actually what our output for 0 is, which it's going to be 4, because that's our y-intercept here. Or of course, we can go and plot it and get our chart to get our outputs. So we get what? X squared plus 2x plus 4 here. And we're going to click second chart and second table. And we can see our vertex here of -1, 3, so we were correct on that. And we see our outputs here, and you can see that we actually, when we plugged in our -3, we got the correct output of 7. So again, finding your outputs via this chart is much easier, but it is, important to know how to plug into the function.